In this problem, I placed a box on a board. I then tilted the board to make an inclined plane. I record the angle at which the box starts to slide. We want to find what the coefficient of static friction is for the box and board it is resting on, and we want to see if the coefficient of friction changes depending on the surface area of the object. So I took a measurement of the angle of the incline when the box starts to move for both the thinnest side being down and the thicker side being down. They are listed in the displayed table. I then took the average of the results. We will first need to go over how to break down the forces of an inclined plane. First, there is the mass times gravity, which goes straight down. Secondly, we have the normal force, which goes perpendicular to the surface of the inclined plane. The angle between the mass times gravity and the normal force is the angle of the incline. Now, the force making the object to move will be referred to as the force in the x direction. This connects the normal force and the mass times gravity to make a right triangle. The object will be experiencing a force due to friction loss that will be holding it in place. This is going in the opposite direction of the force in the x direction. The formula for friction loss is normal force times the coefficient of static friction. Rearranging this formula, we get that the friction loss over the normal force equals the coefficient of static friction. In our experiment, we'll be taking the minimum angle just before the object moves. So this is the angle at which the force in the x direction cancels out the friction loss. So force in x direction minus the friction loss must equal 0. Rearranging this formula, we get that the force in the x direction must equal the friction loss. With that knowledge, we can now plug in the force in the x direction where the friction loss previously was, and the friction loss divided by the normal force equals the coefficient of static friction equation. In order to do the next step, we will need to know a bit of trigonometry. We are dealing with a right triangle, or in other words a triangle with one 90-degree angle. This means that we can use SOHCAHTOA to solve for the normal force leg and the force in x direction leg. So the mass times gravity times the sine of the angle will get us the force in the x direction. The mass times gravity times the cosine of the angle will get us the value of the normal force leg of the triangle. After plugging in those values, we notice that the mass times gravity gets cancelled out. Recall from trigonometry that sine over cosine equals the tangent. So we are left with the sine of the angle over the cosine of the angle equaling the tangent of the angle, which equals the coefficient of static friction. With this formula, we can solve for the coefficient of static friction. So the average coefficient of friction between these two materials with the thinnest side down is 0.283. This is completed by taking the tangent of the average experimental angle, whereas the coefficient of static friction with the thicker side down is 0.279. These values are very close and illustrates that the surface area doesn't make any difference. As long as the objects rubbing against each other have the same material with the same surface finish, it will have the same coefficient of static friction. I would also like to add that due to the weight not being in the formula, it is also not a factor that affects the coefficient of static friction. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thank you for watching.